Hi everyone, welcome to this video. Today I'd like to make a quick video to make an estimation of the case mortality rate of COVID-19. I'm going to do that based on a study done in the Netherlands. Now you can see here on the Worldometer, the Netherlands currently has about 32,000 reported cases of COVID-19, about 3,600, 3,700 deaths have been reported so far. And today, a couple of days ago actually, a study was reported that suggests that 3% of the population in the Netherlands has the coronavirus. I came across this study thanks to a video of this gentleman. This is Dr. John Campbell. He is a nurse. He's been a nurse for most of his career, and then he went into academia, did a PhD, and for the last many years he's been a nursing teacher. And over the last couple of months he's had a daily video where he explains all the scientific information you can find about COVID-19, as well as an overview of how different countries are handling COVID-19. So if you're interested in this topic at all, I would strongly recommend to check out this video and this channel. It's a channel that I follow on a regular basis as one of my sources of information about the virus. So back to this study. So what is this study about? In the Netherlands, they decided to test a large number of blood samples that were donated recently in the Netherlands, and they found that 3% of those had antibodies against the coronavirus. So considering that the Netherlands has about 17 million people, so this was based on a sample of 10,000 blood donations, so 17 million people times 3% is about 510,000 people who can be expected to have the coronavirus right now, assuming that blood donors are a representative sample of the population and that they are also representative in the sense of equally likely to get the COVID-19 virus as other people who are not donating blood. Now there's reasons to argue back and forth whether that's true or not, but let's just take that as a piece of information that we have. Okay. On the other hand, I've been doing modeling for the last couple of weeks of the COVID-19 virus, and so based on this study, I decided to tackle the Netherlands. And I had tackled the Netherlands before, but now, based on yesterday's video, I decided to reanalyze the data of the Netherlands, and here is the result. We see here in orange the reported number of deaths in the Netherlands due to COVID-19, and in blue the model results. So this is a linear scale. The last couple of days there's been a fall off, but it's going back up. I've mentioned that in yesterday's video as well. So I refined the model based on what I found yesterday. So yesterday in my video I concluded that the model is sound as far as the development of the disease, the progression of the disease in a person is concerned. We just need to make sure that we supply enough information about how the country handles the epidemic. So in the Netherlands we know that a first intervention was made on May 15, and that was kind of a wishy-washy intervention. Most of the schools did not get closed and so on. It was more recommendations, not really requirements. And then about a week later, on March 23, the Netherlands imposed a real lockdown, which was a more serious intervention. So it turns out that I get the best fit between the modeled number of deaths and the reported number of deaths if I assume that the first intervention on March 15 was 34% successful. So it reduced social interactions by 34%, and had an additional 58% reduction in social interactions was accomplished starting on March 23. So the infection rate originally was 0.38, which corresponds with an R0 of about 3.8. So in total, 34 plus 58 is 92. So in total, that number was reduced by 92%. So we're talking about 0.3, 0.4 for R0. And that gives us the agreement that we found earlier. Now that is under the assumption that the mortality is 1.5%. Now, the way this model works is I assume a certain number of cases in the beginning of the simulation. The beginning of the simulation is February 1. I assume, in this case, I assume roughly 1/10 of a case of February 1. And that's because there were no cases yet on February 1 in the Netherlands. But based on that number, as a kind of a seed, I can project the number of deaths later on. So the model calculates the development of cases and then assumes that 1.5% of those cases will eventually die following a certain distribution. First they get the virus, then they get sick over the next couple of days, and then they get seriously sick over the next couple of days, and then some of them will die over the weeks that follow. So if I change the mortality, say from 1.5% to 3%, to get the same number of cases, I need to divide the same number of cases by 2 to get the same mortality overall, the same number of deaths. So that way, we can link number of cases with number of deaths. So currently, the model assumes 1.5% case mortality. So let's run the model. There we go. In the long run, we get just under 5,800 deaths predicted in the Netherlands, which is less than twice the number of deaths they have currently, which means that they're over halfway in getting the disease under control. That's very good news for the Netherlands. And then one of the things that the model calculates is the actual number of cases at any given time. So right now that number is about 376,000. The study was reported on day 76 when that number was about 373,000. Let's assume that that study was about a week old, maybe a little over a week old. Let's assume that there were about 360,000 cases according to the model when these blood samples were taken. We know from the blood results there were not 360,000 cases, but there were 510,000 cases. So let's do some math here. If the model assumes 1.5% case mortality rate, it predicts that there were 360,000 cases when these blood samples were taken. We know that in reality there were about 510,000 cases when these samples were taken. So the actual mortality therefore must have been lower because there were more cases. So let's take that 1.5 and let's calculate how much lower that case mortality needs to be to get the right number of cases. So the number of deaths eventually is the 1.5% times the number of cases. So we want the same number of deaths but with a large number of cases. So that means we divide the 1.5 by the number of cases that was actually there. Well, let's do it differently. Let's multiply by 360,000 60,000 cases to get the number of deaths of the people that were infected when these blood samples were taken. If we divide that by the real number of people that had the infection when these blood samples were taken, then we will get the real case mortality rate. And we get about 1.06%. So based on my model and based on the blood sample data in the Netherlands and based on the assumption, that is an assumption, that the blood samples are representative of the population, and based on the second assumption that my model predicts the progression of the disease correctly, based on these assumptions, I conclude that the case mortality rate for the Netherlands is 1.06%. Now, to show that that actually works, let's go back to the model. Let's change the case mortality rate from 1.5 to 1.06. And let's change the number of cases by following that same ratio. So times 510,000 and divided by 360,000. Let's save that and let's run the model again. Again, we get a little under 5,800 deaths eventually when the disease has run out. And let's look at the number of real cases. There we go, that's about 510,000, about a week to 10 days before this study was reported. If you want to be absolutely sure that we did things correctly, I can go to the number of deaths predicted by the new version of the model with a 1.06 case mortality rate and with the new number of cases, and I copy those number of deaths into my Excel file, then you see we get the exact same prediction. So the model predicts with a 1.06% case mortality rate, and with the current, or 2 weeks ago, number of cases of 510,000, being 3% of the population, we can exactly predict or describe the number of deaths that have occurred in the Netherlands over the last couple of months. So there it is, a model-based estimation of the case mortality rate of COVID-19 in the Netherlands based on blood immunological data. In future calculations, I will stick to my 1.5% because I'd rather be a little on the pessimistic side than to be too much on the optimistic side. In most cases, the model, as you can see, is not that sensitive to the number of data because I use previous deaths to predict future deaths, which is not very sensitive to the actual case mortality rate. But I'm going to stick with my 1.5% for now until we can get more confirmation that the number is closer to 1%. There it is. So we know that 1%, 1 to 1.5% is the right ballpark number for the case mortality rate for COVID-19, at least in the developed countries such as the Netherlands. I hope you find this video interesting, and I hope you found the information useful. If you did, please like this video and subscribe to the channel, and I hope to see you again in a future video.